Hey,
What's up?
I'm here for my physics lesson.
Oh, true. What was it on again?
Free fall.
Free fall. Okay, so let me tell you about free fall. Free fall is any object, basically like this watch. Any object that is in the sole control of gravity. You know what gravity is, everyone knows what gravity is. Literally keeps us on the ground. So, free fall, get an object, throw it up. That's free fall. The acceleration for the gravity is 9.8, that's the gravity. That's what's pulling it down, okay? This ball, how it's shaped, it doesn't really have a lot of air resistance. So let's say you were to drop this piece of paper. Look at this. That air resistance is the air resisting the paper from falling to the ground. So, which one do you think will fall faster? That one? Or that one?
So, does mass have an effect on free fall?
Well, yeah, because the heavier you are, the more it's pulling you down. So this is right. That's why us big boys like me and Mr. Cortez, we stay on the ground, you know, because we got a lot of mass. But there's one more thing, okay? If you want to find out equations, there's a bunch of kinematic equations. Jeez, you don't want to know. So, you grab a basketball. I shoot it up about 8 meters, give or take. 8 meters, you get the gravity, acceleration, which is 9.8, okay? And in this next slide, I'm gonna show you how to get the time and how to get the initial velocity. So you're gonna get the distance, which is 8 meters, acceleration, 9.8, and you're gonna put it into these equations that I'm gonna show you. Take it away, Brianna.
Okay, these are the kinematic equations we're going to be using in order to find the initial velocity, and we're gonna manipulate one of these four in order to get the initial velocity. So in order to find the initial velocity, we're gonna use this equation, and so this is how you do it. We're gonna use VF2 equals VI plus 2AD. So you're going to subtract 2AD to the other side. So it's VF2 squared minus 2AD equals the initial. And now you plug it in. So the initial is 0 minus 2. The acceleration is negative 9.8 times d, which is 8 meters. So now you multiply these two, which give you 19.6, and then you're gonna multiply it with 8, which gives you 156.8. And now you're going to square root this, which should give you 12.52 meters per second. Okay, so now that you found the initial velocity, you're going to need to find time. In order to find time, you're gonna have to use this equation and manipulate it, and you're gonna manipulate it by, okay, you're gonna subtract the initial VF minus VI equals AT divided by acceleration. So then you're gonna plug it in, and the final is 0 minus the initial, which is 12.52 divided by the acceleration, which is negative 9.8. And then when you divide it, it should give you 1.27 seconds, and now you found time, which is 1.27 seconds.
Thanks, Brianna, for the math explanation, whatever, you know, all the good stuff. I'm not really good at that, I left it up to her. So, just remember, you manipulate the equation, you get that variable, software. Easy stuff. That's Brianna. Alright, ball. Alright, so remember, free fall. Object falling under the influence of gravity. Air resistance. The air goes around the ball like this. See the air? That's the air, okay? That's how it's able to go down. Remember, the piece of paper did that whole wonky motion in the air because it's not like that, alright? Remember, gravity influences all free fall objects. Doesn't matter up, down, side, upside down, whatever, alright? Thank you guys.